I'll just introduce the folks here. So David Delabasset from Oracle, Yaron Chaviv from Iguazio, and Dave Grove from IBM. So Yaron, two Davids and one Goliath.
We usually like to think ourselves the other way around.
We have a flank.
David.
But they don't know you in panels, so it goes the other way. Anyway, so why don't we start with each one of you just describe the project you represent. The theme here is open source serverless project. So each one just describe your project and when it started, what was the reason for starting it, and then we'll dive into the details.
Yeah. Okay. Perfect. So I'm part of the FN team at Oracle. So the FN project is an open source fast platform that we have just announced 1 year ago. So Oracle is busy building its managed services. It's a fast managed services offering that will be launched early next year. Originally, that project is basically a fork from Iron.io. So a bunch of former Iron.io folks have joined Oracle to continue to work on that. But everything is open source. So Oracle is the major contributor to that open source fast platform, but we also have external contribution from the outside. One of the key aspects of FN is that everything in FN is a container. So you take a piece of code, it will be wrapped as a container by the platform itself. And this gives us many benefits, like, for example, the ability to easily support different language. So that's in 20 seconds what FN is about.
Okay. Yaron.
I'll try in 20 seconds. So you've seen Orit's presentation. We're delivering an analytics platform more oriented to real-time workloads. And we wanted to have an internal sort of storage procedure, high-performance storage procedure engine. We developed something, and over time we said, why won't we decouple this from the actual platform and keep it as a separate open source project called Nucleo? And I think that's why you will see that Nucleo is pretty different than the other project, because it's coming more from a backend workload, extreme concurrency, data integration, etc. So we've open sourced it, has a lot of GitHub stores, and what we're evolving is to a more and more enterprise-oriented solution, because part of the challenges of FAS versus serverless, there's a big discussion around it, is this FAS is usually a component of the system, but people are sort of looking for where's the security, where's the integration with data, management, LDAP, etc.
So we'll talk about these cases in a second.
Yeah, so we've packaged all of that with the platform.
Dave.
Okay. All right, so I'm here representing Apache OpenWhisk. I can't really tell you about the origin stories. I've only been working for the project for about a little under 2 years now. If you want to catch Roderick afterwards, he's in the back. He can tell you stories about the beginning. So Apache OpenWhisk, we're an incubating project at the Apache Foundation. And the project is really about providing a function as a service platform that can be used to provide function as a service either as part of a public cloud offering. So the platform is consumed and provided by IBM as IBM Cloud Functions, or in private or other managed things. So it also runs on top of OpenShift. It runs, and there are other companies that do private cloud deployments as well. I think some of the things that are unique about it is that it really is about providing this entire open source platform where you have a large source of possible languages, so different, very polyglot platform from the beginning, and also looking at all the things you need to do to actually provide a platform that operators or companies can take and actually run production quality, production scale deployments of the service. So really trying to deal with all the issues about how do you have a core software that can be configured in a bunch of different ways to let people operate it in their environments, whether that's a small environment or a big environment, different underlying deployment platforms, whether it's Kubernetes or Mesos or a whole bunch of virtual machines or Docker Compose. There's all sorts of choices that are around the platform. So in some ways, it's a fairly complicated platform to understand and configure, but it gives you a whole bunch of options to do this, and we have a focus on performance and scalability and really trying to provide an open source, common way to look at this stuff where multiple companies can come together to work and put the software together.
So let's talk use cases, because at the end of the day, you have to kind of pick which use cases are you focused on, especially at this relatively early stage of the industry. So maybe we'll start with you. I mean, what do you see a focus there, or it's like whatever, any kind of application you would, or do you recommend specific use cases areas?
Right. I mean, so I think if you look at, it's come up in a couple of talks earlier, we sort of looking at the IBM cloud, we have basically 3 compute platforms that are there. We have Cloud Foundry, we have container services and Kubernetes, and we have functions, which is based on OpenWhisk. And so it's fitting that niche of the sort of serverless function as a service. And in terms of what people do with that, we have bursty batch processing, we're backends of mobile apps, we're backends for IoT applications, and just, one of the things that's interesting is there are a lot of people doing things with it, and the platform basically works, so a lot of the times we don't actually know what our customers are doing. They're just doing stuff. And basically almost, and then, and another common use case is, we were talking earlier about, it's an orchestration layer. So it's basically piecing together all the other services in the cloud and providing that serverless orchestration that ties the services together and does the impedance mismatching between the various parts.
So, as you know, in our platform, we use Nucleo as a way for customers to program functionality in. So it has to be a bit broader on the scopes. It's not just event-driven that we are seeing. And so the leading use cases are more around real-time analytics, where we use Nucleo in those four main steps for ingesting data and normalizing and labeling it, for inferencing. So there we even know how to run like Nucleo with Spark. So Nucleo can actually run Spark within, or TensorFlow for some of those functions, generate triggers. And now the key verticals are around network operations management, including service management with different telcos, financial applications like risk, fraud, trading, trade monitoring, IoT scenarios. One of the things that we've done together with Microsoft, we built an edge solution, which is co-sold by both companies. And that was actually a trigger for Microsoft to make a huge contribution to Nucleo. So they've contributed a lot of integrations that are native now into the Azure services.
David?
So to go back to what Dave said, I think that orchestration at the function level is something that we are seeing more and more. So being able to serve that kind of use case is something that is important.
Okay. Now let's talk standardization. Just before starting this, we were talking about CNCF as kind of the forum where all these things are being talked, but right now we see complete different type of services, APIs. Do you see any chance of some sort of standardization, especially when you talk about the different cloud services? And now when you take some of these platforms to on-prem, so people are getting confused. What to use there?
So I'm coming from the Java world, so where standardization was key. And standardization was really needed, 20 years ago, really to foster the ecosystem. I think that having standardization within this space is important, but we have to be pragmatic about what we standardized. So we should find the right balance between what we need to standardize and what the market is expecting. And I think that we have to be pragmatic about that. So, for example, what is being done regarding workflow at the CNCF level is something that is important. But we shouldn't try to standardize too much, because at the end of the day, we have multiple players. So we also need to make sure that we don't spend too much time on standardization effort, and we also need to make sure that we basically keeps our ability to innovate together, well, in parallel, and we still need competition in that space. So standardization is important, but we have to be pragmatic about it.
I think there's sort of like standardization from the top level. So like CNCF, like cloud events, there's a good envelope format specification, so we can all talk events. You don't have to worry about what's inside, but you can sort of get the data moving around. And I think there's also sort of standardization coming up from the bottom as we sort of understand more about what the basic platform has to look like. So for us, within OpenWhisk in the last year and a half or so, we made a big shift from deploying on clusters of virtual machines, which we manage and operate ourselves, to deploying on top of Kubernetes in production. And that made a huge difference for us in terms of ease of operation. And so I think as you sort of have that base layer coming into play, as Kubernetes being the base layer underneath you, and you're building the next layer on top of that, where exactly the stuff fits, whether it's in Kubernetes and Knative and other things that build on top of it, it's unclear. I think that'll be figured out, but as we sort of the industry sort of moves these layers up, we can sort of stop worrying about them and stop doing heavy lifting there.
You're right.
Yeah, so I'm pretty active on those standards, and Cloud Events was one of my my initiatives, along with Doug and a couple of other.
Speak up a bit.
A couple of other folks. We had some big ambitions on standardizing a lot of stuff, and we've created priorities. The first thing that we wanted to standardize was the triggering mechanism, because if you go to Lambda, it's limited to like Kinesis and HTTP and a few proprietary services, and even there we've showed Amazon that for each of their own services has a different signature envelope. So a guy writes code for Kinesis, writes code for HTTP, actually has to change his code if he's using different triggers. And that's sort of a different approach that we've taken in Nucleo, is to normalize everything to a structure that's common across all of those, and then you don't really care where the trigger comes from. And then we've sort of pushed that into the cloud event together with the rest of the companies. We tried to do, and that succeeded, and now it's a standard, and I think FN supports cloud events, and OpenWhisk, and Azure functions. Amazon is still sort of hedging. Google supports cloud events. Other things we try to do is also the specification of the function, but it's pretty hard, once you get more and more people involved in those standards, it's pretty hard to push.
So you mentioned cloud events. Maybe you explain a little more what it is, because some people.
So essentially, the idea is that when a function is being called, you don't really care what call the function.
So it's a standard in CNCF.
It's a standard. I don't know if it's already a ratified standard, but it's sort of a pre-standard.
Okay.
It's a pretty standard. There's already a draft. I'll show a slide on my presentation. We've done interop demos already to show all the frameworks working with this. But I think other things that we try to do, because we see this sort of anti-standardization now, we created a lot of interfaces. So for example, today from Nucleo, you can throw logs to Elasticsearch or to App Insights or to other things, and trying to push others, members in the industry, to adopt those abstraction layers with us.
So do you see any chance for multi-cloud in this space?
I think the biggest thing around multi-cloud is, as you guys mentioned, around Kubernetes, because that's becoming sort of a common substrate. If you think like 2-3 years ago when Lambda was invented, or 5 years ago, there was no Kubernetes. Okay, now the cloud providers provide you a managed Kubernetes, which is sort of serverless containers. Okay, all the security, all those things are sorted out, and the advantage is Kubernetes sort of standardized around everyone, same API. So I can essentially run some layer on top of each one of the cloud provider services and still create sort of a serverless experience.
Yeah, Kubernetes has become the de facto standard.
So that's helping standardize from kind of the bottom?
Yeah, it certainly simplifies that effort.
Yeah, I think it's sort of harming Amazon's sort of efforts, although they sort of jumped on the wagon after it was sort of already there, because it's easier to go and leverage the features of Kubernetes for a serverless framework. There's GPU support, supported in Kubernetes. Okay, my function supports GPU. And if you've developed your own framework, you have to keep up with the industry. And that's something we've seen around open source in general.
You want to say something?
I think it's definitely sort of standardizing the compute piece of it. And the other piece of it, which maybe would be very valuable, but I don't know how to do it, is getting all the other services around it that you're trying to connect to. So having a more standardized way to figure out what services you need to connect to, how to deploy them, how to manage their life cycle, how to react to them going down and replacing them, and so on. That's a big missing piece, I think, right now.
So talking about the cloud versus on-prem, could you assess how much of the effort in each one of your projects is actually dedicated to making it ready for the cloud versus actually making it also applicable for on-prem deployments, which are still big, especially in the city?
That's a tough question.
I didn't say it's going to be easy.
No, right. First, there are use cases where it makes sense to have a fast platform on-prem. The thing is that you have to realize that typically there are two types of users. There is the fast user, so the function developer, and the fast operator, the fast platform developers. So if you are okay with that, if you are okay to cover the two roles, and if you acknowledge and understand that there is a cost to run the platform, there are use cases where it makes sense. Typically, when you have strong local regulation that basically you need to comply with those about how you deal with the data and so on. So now if we look at so Oracle is focused on two things, the open source project, and we're also building our managed services that is based on the open source project. But given that the managed services is running on top of Oracle Cloud, I wouldn't say that you can just take FN and in 5 minutes it will run in any other cloud provider, with elasticity and so on. Doing a basic setup, it's just a 5-minute effort. I've done it last week. But yeah, there are efforts that you will have to pay if you want to have the full-blown solution running in a different cloud provider or on premises. So it doesn't come for free.
So you're saying most of the effort is around cloud?
No,
And-
I mean, no, because at the end of the day, I mean, it's hard to say how much effort we have on that side versus on the other side, but there are still effort to be
In terms
made.
of usability, because at the end of the day, it's about, okay, taking it, using it, so it's kind of the non-sexy stuff, I mean, the peripheral stuff around the project that makes it kind of more adaptable for the cloud versus on-prem.
Yeah, so there are works to be done, but most of the pieces are there. So FN is not open core. So I mean, everything that we have on the GitHub organization is what we are using for the managed offering that will come later on.
Dave?
I think we put a fair amount of effort into both of them. It's really if you sort of look at how Apache OpenWhisk is being used, IBM primarily deploys it on the public cloud right now. Some of our other partners providing or putting it on the private cloud that are working in Apache OpenWhisk, so it works in both already. And I think a lot of effort is around you have the core system, but then you've got to integrate with the platform's logging systems and monitoring, tracing, everything else around that, IAM, whatever that is in the private or the public cloud. And then there's also, getting back to there's the developer perspective and then there's the operator perspective. So when you take one of these functions, open source functions as a service platforms and deploy them on a private cloud yourself, you're taking on the operator's role as well. And that's still, at least for OpenWhisk, there's a fair amount of care and feeding around keeping the platform running, at scale and getting the kind of uptime you want, on the long scale. And so that's something that needs more effort probably to make those things easier to do for people who are deploying on the private.
Ron?
Yeah, yesterday we had a chat with Kelsey over dinner, and he said, you know what, serverless is a feature of a platform. Serverless is not a platform, and I think it was very evident in his presentation today where he sort of used all the Google services. So we have a platform, which means that we have, LDAP integration and all those things. So it allows us to, and data services and management, logging, monitoring. So that allows us to provide a turnkey solution also for on-prem. But what I see, I distinguish between 3 use cases, not 2. It's not cloud and on-prem. I would look at cloud, on-prem, and edge. And the difference between on-prem and edge is on-prem is very oriented towards IT. Okay, we have our IT, we want you to sort of align with everything we've built in the last 10 years. And edge is something else. It's sort of just like your set-top box at home, your Comcast box that may sit in a factory, may sit in a sort of oil rig or whatever. It's still managed in the cloud, and it's less opinionated. That no IT guy is going to touch it. It's sort of a black box managed from the cloud. So I think Edge has a lot more potential success with serverless, just because people won't try to tear it down and say, no, we have different opinions. On-prem, it depends on the customers. Some customers are extremely opinionated and want to focus on why did you build it this way, we can do it differently, etc. Probably won't move fast enough in adopting it. Other users that are more focused on, okay, you know what, that's great, now we want to build applications on top of it, probably will be quicker adopters of serverless.
If I can add to that, so there's cloud, on-prem, edge, and there's also local. It has been mentioned multiple times today that for developers debugging and testing is kind of difficult. So having the ability to take an open source fast platform and running locally on the developer laptop is a key benefit for those solutions.
I agree. So switching gears, all of you are, I would say, evangelists of serverless, I would say. And you bump into people that want to start using serverless, testing it. What are your key recommendations, the tips of how to start it in the proper way? Because I'm sure that some of the people here are just at that stage.
So the first thing that I'd like to know from them is why they want to go serverless. I just want to make sure that they understand where they are going to, and the advice is to go incremental. So not try to rip and replace just because, serverless is cool. It's just yet another tool at our disposal, and where it makes sense, we should leverage fast. But so that would be my first step.
I agree that we first need to have some use case in mind if you want to build an application. And you would need to, especially in our solution, it's focused more on like concurrency and things like that. So if you have something like that, I wouldn't try to recommend writing something from scratch, rewriting a code that you already have. It's more around if you need something to glue together initially, I would suggest serverless.
Yeah, and I think using it to orchestrate gluing together new applications, piecing together services makes a lot of sense. And I think echoing something from one of the other talks this morning, I forget who said it, which is unfortunate, but they're talking about the need to, I think, think about your architecture differently. So it's definitely, don't just take an existing architecture and try to make pieces of it serverless. Really sort of rethink about how does it make sense to put this application onto a cloud-native footing, which piece of it should be serverless, which pieces of it actually really shouldn't be, and how do you put those together? You need to really sort of rethink that whole thing and get that to work.
So the flip side of the same question, do you have examples of wrong use of serverless that you don't recommend people doing, making the same mistake like from that experience that you had? Could be funny, something like that.
No, the only anti-pattern would be that I know of, is basically trying serverless to do web apps. I think that's not a good fit. It has been mentioned today. So, but the thing is that we are pretty new in that space, so we don't have a lot of history or background to basically assess what are the good use cases and certainly what are the bad use cases.
I think overall people need to be bought into the concept of cloud native, which is elasticity, CI/CD, those kind of things. And if they're not, we had some case that someone wanted to write a code for his own laptop and he thought that serverless is the right way to go. So probably not, because the whole idea about serverless is also automating the operation aspect of delivering software. You change something, rolling upgrade, etc. So if it's just for your laptop, your own app, write in Python and that's it.
I think this may be a OpenWhisk specific thing, but one of our issues is that we have an at most once execution model. So if you're doing something where it's really quite critical that something runs exactly once, it's going to be very challenging for you to retrofit that onto a platform that's going to have best effort execution and may not even tell you whether something executed or not reliably. And so you'd have to build all that externally. And so if you have something where you have some pieces of code, business logic that has to execute exactly once, that's not a good fit for us, at least in the current moment.
So AI, it's associated many times with serverless functions. Could you give your perspective why that link exists and how your project fits there?
Yeah, we like AI because that's sort of our main use case, but I think...
But why? What's the
because
story
AI
of
have the different components that also already demonstrated. The first thing is generating metadata on variants, whether it's like the stock ticker we've shown or just sentiment analysis. Now there are a lot of libraries today. You go to Python, there's NLTK, you have all the other functions that it's very easy to create a single function that, for example, takes text and generates some metadata out of it, or even takes like Kelsey example. And today a lot of those services are even in the cloud, are productized, just like you've seen, there are cloud provider services, so only thing you need is sort of a glue logic to generate some input data, run it against some API or some library function that was written in Python, generate some output and serve the output. I think also in many of the serving use cases, you need the ability to scale, because if you have a use case of, let's say, customer recommendation engine, and now there are only 100 people on the site, or now tomorrow there's 100,000, you have the ability to automatically scale the inferencing. On the machine learning side, it's more tricky because it's usually more of a stateful problem, massive amount of GPUs, etc. It's less, optimal for serverless. But the serving portion or the ingestion, the ETL part, is definitely a good match with serverless.
And the inference part?
And the inference is sort of the serving. This is also a great match because, again, the ability to scale, and also there's a thing that people don't yet internalize the benefit of serverless for this. Usually, when you do inferencing, you have a model associated with your code. Now, if you find a way to create a single artifact that incorporates the machine learning model and the code that uses that into a single sort of Docker container that contains both, and then you could do sort of rolling upgrade of both together, it simplifies all the delivery of those serving applications.
Yeah, I mean, I think it's good because you have the scaling, it's potentially compute intensive, there's lots of data involved. I think there are some interesting challenges in there, especially if the model, if you're trying to do inferencing and the model requires a fair amount of data, you may not have a hot, warm container all the time, and so continually reloading the model so you can serve it can be a bit of a problem. I think there's some traps there around, how do you make sure that you can actually have the data you need.
Or do shared volumes like we announced today. But
Sorry. You need something,
Yeah.
and so you've thought about that.
And are you using the serverless in Watson? Planning to?
Yes, quite a bit of Watson uses the cloud functions as under the covers to do things.
And what part of the process within Watson uses it?
I think mostly on the serving.
The inferencing.
There are other. Some of the training side is more compute intensive, large data sets, and so they have additional services for that are more Kubernetes based.
Okay, so thank you very much, David, Dave, and Yaron.